Hello everyone. Once again, we return for another example of shorthand integration using the quick method of shorthand substitution from my last video. Today's integral will be for the expression of x squared multiplied by the tan of x cubed. Now, I've gotten some feedback from the last video, mostly positive, and it involved adding more effects and more changes to how the information is being presented, which I will do in the future, but please bear with me until I can get to that point. The most important thing for me right now is to continue making these so that we can achieve greater success in the future. Now, right off the bat, you'll notice that I did the same thing I did in the last video and integrated x squared into the dx to give us dx cubed. A factor of 1/3 is produced in the process because the integral of x squared is x cubed over 3. That 1/3 can be moved out of the integration sign because it is a constant. It is very important to preserve these constants or these factors so that you do not lose track of how your integration is being scaled. Just because we're using the shorthand method does not change how integrations are done in general. Just like in the last video, we split the tan into sine of x cubed divided by cosine of x cubed, since this was tan of x cubed. Similar to last time, we now integrate the numerator sine x cubed with respect to dx cubed to give us negative cosine x cubed in the differential. In other words, d cosine x cubed. Similar to last time, d cosine x cubed divided by cosine x cubed can also be shorthand integrated into ln of cosine x cubed. Now, it's very critical to remember that we have a negative and we have a 1/3 as a result of the two previous shorthand integrations. So those need to be preserved. And since we ended up with an ln as the final answer, we can take that negative on the outside and pop it into the ln in order to invert the cosine of x cubed. This gives us 1 over cosine of x cubed inside the ln. 1 over cosine x cubed is simply secant of x cubed. So your final answer is going to be 1/3 of ln secant x cubed. Now, some people are iffy out there about the arguments that can be allowed into the ln. So if you feel the need to, you can go ahead and add the magnitude of secant x cubed instead of just leaving it as is. That way, ensuring that all the arguments of ln are greater than 0. Thank you guys very much for coming to this video. And if you like what you're seeing, please hit the like and subscribe button. And I will see you next time. Have a good night.